Hello. In this video, we're going to finish up evaluating those limits. I have got some graphs just to make these graphs a little cleaner than me drawing them like last time. So the first one, we have 1 over x. We know that this is just a normal hyperbola. We can also plug in 0, and we know that we're not allowed for this to happen. So this does not exist. We can confirm this by understanding that the left and right side go to negative infinity, positive infinity, different directions. As the limit as x approaches infinity, we need to do our techniques where the numerator degree, the degree in the numerator is degree in numerator is 0, degree in denominator is equal to 1 because the coefficient of because x to the power of 1. Thus, the denominator degree is greater than the numerator degree. So our limit goes to 0, the same as the horizontal function for both of these. And we can confirm that by looking at the graph. As I continue going right, it goes to 0. As I continue going left, it goes to 0. Never crosses because we have a horizontal asymptote at y equals 0. All right, next. The next one, we have x plus 4, x minus 2. We have an asymptote at x plus 2. And yeah, we have an intercept here. So here we go. As x approaches 1, we don't have any issues. As x approaches 1, we are on the left side over here because this is 2. So the 1, and it's going to be, just got to plug it in. So we have 1 plus 5 all over 1 minus 2. We have 6 over negative 1. We have negative 6. Beautiful. We look at 2, we have an issue. Why? We have x plus 4, which is 2. So 2 plus 4 is 6 over 2 minus 2, which is 0. That does not allow, does not exist. We need to confirm that with the graph. We see, all right, it approaches negative infinity, then positive infinity. So 2 different directions. Again, when we're doing this now, we see that the numerator this time is the same degree as the denominator. The degree for the numerator and the denominator are both the same. When that happens, you just take their coefficients over each other, which is 1 over 1, which is equal to 1 for both of those. We can confirm that by looking at the graph and see that both of these will get closer and closer and closer to the value of 1, but never cross. Let us continue. We have to factor the denominator. We get x minus 2, x plus 2. We cancel out the numerator and the denominator. We have 1 over x plus 2. Now, we graph this and we see that we have an asymptote at x minus 2. Everything else is going to be fine. Plug in 0 for our after canceling. We have 1 over 2. Plug in negative 2. We have 1 over 0. We have an issue. We check our graph. We see the positive and negative limits because the limit from the left is negative. The limit from the right is positive infinity. The one from the left is negative infinity. So the limit does not exist. As x approaches 2, we're just going to plug 2 into the top. Wait, no, sorry. 2x does not equal 2. We have a hole, but the limit does exist. Right? So the limit does exist, and it is 1/4. But plug in 1 plus 2 on the bottom. Box these answers up really fast. Okay. Now the limit as x approaches infinity and negative infinity, we have to again check the degrees of the numerator and the denominator. The degree in the denominator is greater than the numerator. The degree on the denominator is 2. The degree on the numerator is 1. Again, just check the exponents of the x. So this means that our horizontal asymptote is y equals 0, and both of these values will go to 0. And we can confirm that with the graph. Lastly, factor the top, cancel with the bottom, and we have a brand new graph without any denominators. All of these things are going to work. We just have a hole at x equals 2. But the limit still exists there. Plug in 2, we get 4. Plug in 0, we get 2. And we can show you what we mean by this, because this is just a simple graph of x, a linear graph of x equals 2. And we see that the y-intercept is 2. Our slope is 1. We have our simple line like this. We just have a hole at x equals 2. This value does not exist. Hole at x equals 2. But you can see the left limit and the right limit both approach that same value. Now, as we keep going to positive infinity, I'm just going to keep rising. We're going to go to positive infinity. As I go towards negative infinity, we're going to keep going down, and we're going to get to negative infinity. Those are all those values. Solving these limits wasn't too bad. If you have any other questions, please let me know. Other than that, hope everyone has a great day.